Namaste, welcome to all. Today we'll discuss formulas for series of a binomial coefficients. Binomial expansion of a plus x whole power n we know. nc naught a power n, nc1 a power n minus 1 times x, nc2 third term a power n minus 2 x square, and the last term will be ncn and the second variable with highest index x power n. Suppose if you take a plus 1, then what you will get? And even this nc0, you can no need to write n. If you write c0 also okay. 1 power n, 1 if you raise to whatever power, that is 1 only. So c0, c1, c2. Here 1 power n minus 1, 1 x will be there. c2, x square, so on. Finally, what you will be having? ncn means just cn if you write, that is enough. X power n will be there. Okay. In this you can take it as first equation. If you put 1 or minus 1, you are going to get some of the binomial coefficients. Okay, if you put 1, what happens? You see. Put 1 in this, you can write this as first equation. Okay, put 1 in x equal to 1 in first equation. What you are going to get, you see. Here this side c0, x is also 1, so c1 into 1, c2 into 1 square, that is 1 itself, dot dot dot. cn, 1 power n is 1 only. That side x place you have to write 1, you see. 1 plus 1 whole power n. That is how much more? That is nothing but 2 power n. So sum of the binomial coefficients is, no need to find all binomial coefficient and add. Just if you calculate 2 power n, that is enough. You'll get sum of the binomial coefficients. Next, you put minus 1 in 1. If you put minus 1 in 1, what you are going to get, you check. Okay. X place you are writing minus 1, no? Right. So C0, C1 into minus 1, so minus C1 it will become. C2 into minus 1 whole square if you do, plus 1, no? If you raise to even powers. So that is C2. If you are having another term like C3, C3 x cube will be there. Minus 1 if you raise to 3, it is a minus only. So minus C3 plus dot dot. Okay, if you want to write n term means minus 1 whole power n cnc. Okay, like that it is. So this sum of this series is 0. 1 minus 1, 0. Okay, this will be 0. Okay, here instead of this you can write 0. Okay, no issue, no problem. Okay, next what happens? Here see, minus c1, minus c3, like the terms are there, no? That you transpose to that side. Minus c1 if you transpose to that side, you are going to get. So this sum, what we thought, it is 0. This sum of the series. Minus c1 you are transposing to that side, plus c1 it will become. Minus c3 if you transpose to that side, plus c3 it will become dot dot dot. Now that will be equal to, okay, only this negative terms you have transposed. Remaining terms what we are having, c0, c2, dot dot dot. So some of this series and some of these series are equal. That is odd power coefficients and some of even power coefficients are equals, like that. Okay, one more thing. This result I will take it as Roman 2 and this I will take it as Roman 3. Okay, I'll solve Roman 2 and Roman 3 to get some more results. Okay, I want to solve which one? Roman 2, where I found some of the binomial coefficients C0, C1, C2, C3 and so on, that I got as 2 power n. And if I take, when I put x equal to -1, I got C0 minus C1 plus C2, alternatively plus and minus like that, minus C3 plus so on. This sum of the series I got as 0. If you solve them means you can add or subtract C. If you add them, what happens? Plus C1 minus C1 will get cancelled, plus 3 minus 3 will get cancelled. C0 plus 2, C0, twice C0, twice C1 like that I'll get. Even 2 you can take common if you want. So C0 twice C0 plus C2 plus so on. Next term will be C4 like that. This sum of the series will be equal to 2 power n, twice sum of this series. Then what happens to C0, C2 and C4 and so on. So sum of even power even binomial coefficients, what it will become 2 power n. That 2 if you send this side divided by 2, 2 power n divided by 2 is nothing but 2 power n minus 1. Similarly, and you already have showed this sum of the series and this sum of the series are equal, odd power coefficients. Then odd power coefficients will also be 2 power n minus 1 only. See. Okay, using sum of the binomial coefficients, we can find formula for others also. See. Oh, how many means? Okay, one good example we'll take, ideal example it is. Okay, how you can find means, here directly we cannot find, we have to do some manipulations. What manipulation we can do means, we know the formula of sum of binomial coefficient. First we'll write that C1, C2, okay. Thrice C2 is there, but we'll write C2 here, C3, you can write like that, and Cn. Okay, why I'm writing this, I'll tell you. And see here, C0, okay, twice C1, but you wrote one C1 only. So remaining C1, you have to make another series like plus here 3C2 is there. Here C2 only you wrote. So remaining 2C2 you will write here. Next here 4C3 will be there next step. Here 1C3 you wrote. So another 3C3 you have to write here. Okay, like that if you continue, what the nth term will be there means here 1 Cn you wrote. Remaining n Cn you have to write here. See. Okay. See why I manipulated like this means these are the sum of the binomial coefficients. I already know their formula, that is nothing but 2 power n. So if I find the sum of this series, then I'll come to know the formula of this. Okay, that I will do. Okay, how I can find this means I have to expand that. C1 you know, C1 is nothing but NCN, you know, N only will come. Okay, here twice NC2 is there. NC2 if you expand N, and see, you no need to use the formula, NCR formula. You can write, we can write here 2 is there means R value. We have to write 2 factors from N. N and its next factor will be N minus 1. 2 factorial means 2 into 1. 2 you can write itself. 2 into 1 if you want, you write. Okay, that won't make any difference. Next, 3 times NC3 is there. Now, 3 is there means 3 factors from N you have to write. You have to reduce N minus 1, N minus 2. If you reduce 1, you will get the other factors. Now, down 3 factorial you have to write. This is a short way to find. 2 into 1. Okay, binomial coefficients we know how to find and all. That only we did. Next, see. Here N. NCN value, you know what it is 1. Okay. Now what else we can do means Here in all the terms, you are seeing n common. See, n is common in all the terms. So n will take common. So what happens? We'll see. N, if you take common, 1 here, entire term you are taking common. This two can be cancelled. So what is there? N also went away. N minus 1 is there. See. Okay. Next, here what happens? 3 got cancelled. So n minus 1 times n minus 2 whole divided by what you are having 2 into 1. So they are also binomial coefficients starting from n minus 1. Okay. This entire term you took common 1, n you took common. Okay. They are see directly you can write they are also binomial coefficients. Sum of binomial coefficients starting from n minus 1. That sum will be nothing but 2 power n minus 1. If you are unable to follow, I'll write some more steps. See, to understand, I'm writing some more steps. Here we can get the answer, but I will write some more steps to understand. What I'll write now? N minus 1. It is starting from n minus 1. That will take it as some other variable n, capital N. Capital N I am taking. This 1 I can write it as capital N C0. See NC0 1 only, no? NCNR NC0 1 only, binomial coefficients. That we know. This what I can write, n minus 1 I can write it as n. That n you can write it as nc1. Okay. Now this is n and capital N it is. And this is capital N minus 1 and divided by 2 factorial. That is nothing but, if you write in terms of binomial quotient, capital N C2 it is. Okay. This one, you can write it as N C N. No? Okay. So some of the binomial coefficients only, starting from capital N. Okay. So n into, okay, 2 power n. Just now we know some of the binomial coefficients you can know. 2 power n. Okay. So now the sum of the binomial coefficients of the given series you can find easily. That is 2n. Here you have to restore n capital N with small n minus 1. See, its original value. N times 2 power n minus 1. Okay. This is the formula for the series C0 twice C1 thrice C2 so on n plus 1 Cn. It's what is the formula means 2n plus n times 2n minus 1 is the formula. See, like that we can find for so many other series also. See, just you have to understand the patterns. See. Here C1 plus twice C2 plus thrice C3 plus dot 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 NCN. What you got? N times what you got, this formula. This especially what we got, we'll write here 2 power n. This is a normal sum of the binomial coefficients. This what we got, n times 2 power n minus 1 you got. Okay. Like that, see, some other series is there. That also you can find. You have to just understand the patterns. Suppose if you are having 1 into 2, 1 into 2 times C1. So this is, I'm telling you some extra, see, not the, I'm not talking about this series. This over, we found its sum. Okay, now one more series if you are having, like 1 into 2 C1, 2 into 3 C2, so on. Okay, you can write the third term and nth term. Similarly, you can write. Okay, that somehow you can guess, no? Here 1 into C1, 2 into C2, 3 into C3 means n into 2 power n minus 1 will come, no? Like that 1 into 2 into C1 means n into n minus 1, see. Okay, that is n into n minus 1, 2 power n, like that it will come, see. 2 power n minus 2 will come. Okay, similar kind of manipulation we can do. It will come as n into n minus 1 times 2 power n minus 2. Okay, like that, some more series if you know the formulas. Now, if they in actual exercises, they will give some other series. For that, if you want to find formulas, means you should at least memorize some series formulas like this. C0, one more important is C0 times CR, C1 times CR plus 1, and so on. C2 times CR plus 2. Okay, such series there means their sum will be n into 2 power n minus. No. This is 2n factorial. 2n factorial. Its sum will be 2n factorial by n minus r factorial, okay, into n, this you have to write, n minus r factorial into n plus r factorial c. Okay, this is the formula you have to memorize. C0 square, C1 square, C3 square. In earlier terms only, both are C0 means instead of CR, C0 is there. There is no gap. This C1 into C1, C1 square it will become this C3, C2 square. C it is, sorry, C2 square. Okay, Cn square finally. What you will get? No, same this only. Here there is no gap. No, so n minus r factorial, n plus r factorial will not come. See. What it will come is numerator to n factorial only. Down there is no gap, no, n factorial into n factorial will come. So what you can write? N factorial whole square you can write. Okay, whole square you can write. Let's say one more series, C1 plus C2 whole square plus C3 whole cube plus so on, Cn whole power n. This also easy, you can find. Its sum will be 2 times 2 power n minus 1. Okay, just memorize this sum of few series of binomial coefficients, then you can solve any problem in the exercise. Any problems in the exercise. Just you memorize few formulas. Mine first thing is sum of binomial coefficients is 2 power n. With that we can derive we can find formulas for some more series, which will help you to solve the exercise problems or any problem you can find. Any series you can find the formula having binomial coefficients. Hope this session is very useful. Please like and subscribe for more videos.